Welcome to FEMSA Medu Consultancy channel. In this video, we'll be looking at more questions on trigonometry, and these are other aspects of trigonometric questions. Okay, so 2006 stroke 07 or 07, we have two questions that are linked together. The question says use tables to evaluate question 23 sine 230 degree and question 24 tan 225 degree. Now, how do we solve this problem? That particular year, okay, when they say use table, they are simply referring to statistical table, okay, where there is no room for the use of calculator, but I don't think it's the case today, okay, because you can easily punch this on programmable calculator to find the direct answer. Or should this be a theory question? How do we show how we arrive at this? So what they want you to do when they say use table is that they do know that inside the statistical table, or what you call the four-figure table, angle 230 degree is not available. So what are we going to do? Now you will now realize that this angle 230 degree can be equivalent to an angle in the first quadrant, because this angle lies in the third quadrant. Don't forget that each quadrant is a quarter of a circle. All right, a quarter of a circle can accommodate 90 degrees. So the first quarter first quarter of a circle will have angles between 0 and 90 degrees. The second quarter of a circle will have angles between 90 degrees and 180 degrees. The third quarter of a circle will have angles between 180 degrees and 270 degrees, and the fourth quarter of a circle will have angles between 270 degrees and 360 degrees. Each of those quarters is what is referred to as a quadrant. Okay, so 230 degrees lies in the third quadrant. Okay, that's angle between 180 degrees and 270 degrees. But sine of this angle is also equivalent to another sine of an angle in the first quadrant. So our duty is to see how we can rewrite this this particular sine of this angle in terms of an angle, sine of an angle in the first quadrant. So this is what we are saying. But that will make me to let you know that, okay, permit me to quickly illustrate. Okay, let me do it this way. Solution now. We have sine 230 degree. So let me quickly do an illustration for you to see what we are talking about. Look at this. So imagine this is a circle, this is a plane, and we have divided that plane into 4 equal parts, and each part is called a quadrant. So in this part that we call the first quadrant, okay, all the trigonometric ratios in this quadrant are positive. In this second quadrant, that's the second quarter, it is only sine of an angle that is positive. Every other trigonometric ratios are negative. Now, I meant that of sine, the cosine, and tangent. Okay, I'm not referring to inverse trigonometric ratios now. Alright, because if I'm to refer to inverse trigonometric ratios, both sine and cosine will be positive here. Alright, so but I'm referring to those 3 basic trigonometric ratios. In the third quadrant, it is tangent that is positive, and in the fourth quadrant is the cosine that is positive. Now, our duty is now to check where does 230 degree lies within this quadrant. In this quadrant, I have between 0 degree and 90. Here is between 90 and 180. And here it is between 180 and 270. Okay, so in this particular quadrant, only tangent is positive. That means sine of an angle is negative and cosine of an angle is negative. So I'm to look for sine of angle 230 degree. I already know, because 230 degree lies in the third quadrant, my answer must be negative. Now, I am working this out without the use of calculator, and I still want to make use of my table. That's the four-figure table or the statistical table, as the case may be. So I know that my answer will be negative. See what I'm going to do. This will be the same thing. It will be equivalent to negative, because every trigonometric ratio of angles in this quadrant are positive. I know that my answer is going to be negative, but if I can get an acute angle equivalence of 230 degree, okay, in this quadrant, I will just attach this negative sign to it. So how do I get the acute angle equivalent of all the other angles in this quadrant, and in this quadrant? My duty is now to reflect. Maybe I may do that in another video of how we come about those acute angle equivalents. But I will just tell you in this particular video that in this second quadrant, the acute angle equivalence of angles in the second quadrant is simply 180 degree minus theta. Now that shows that every angle in this quadrant are lesser than 180 degree. The moment you subtract that angle from 180 degree, it will automatically reduce it to an angle in the first quadrant. Now, in the third quadrant, the acute angle equivalence is just going to be theta, here, theta minus 180 degree. The moment you subtract 180 degree from that theta, because theta in this case is greater than 180 but less than 270, the moment you subtract 180 degree from theta, it will automatically reduce the result to an angle in the first quadrant. And in the fourth quadrant, the acute angle equivalence is going to be theta minus, 360 degree minus theta. Okay, so now that shows that I can always convert any angle in any of these quadrants to an angle in the first quadrant. So now look at it. My sine theta, okay, let me write the generalization. Permit me to write for third quadrant, sine theta. Okay, when I say third quadrant, I meant 180 degree less than theta, theta less than 270. Alright, sine theta in this case will be equal to what? It will be equivalent to minus sine. The acute equivalence will now be what? That's going to be theta minus 180 degree. Alright, so in this case now, this implies that my sine 230 degree will now be equal to, or it will be equivalent to what? Minus sine 230 degree minus 180 degree. And that's going to give me what? This one will now be equal to what? Sine. What is 230 degree minus 180 degree? That's 50 degree. So you can see that angle 50 degree is going to be available in the statistical table or the four-figure table, so which can easily be gotten directly. If you check that table, of course I don't have the table now, but I can now use my calculator just to improvise. You will see that sine 50 degree will give me 0.7660. So my answer to this question is option A. Alright, that settles that, but we are not done yet. We have to find tan 225. Very easy, because angle 225 also lies in where? In the third quadrant. Okay, so our duty is just to, that means for 24 now, question 24, that means tan 225 will be equivalent. Then you pause. 225 lies in the third quadrant. Which of the trigonometric ratios is positive in the third quadrant? You will realize that it's tangent. So that makes it easy for me to conclude that if I'm going to write the acute equivalence of this, my final result must be positive. So this is same thing as positive tangent of the acute equivalence. Now, acute angle equivalence will now be 225 minus 180 degree. So this will give me what? Tan, that should be tan 45 degree. And if you check your statistical table, or which is the same thing as your 4-figure table, use your phone, your calculator, that will give you 1. Tan 45 degree is 1. It's positive. So we have this, and that's going to be option D. Okay, so I think that settles it. So that's another area. It's not as difficult as it applies. It's just because I had to do this explanation. So we have another question, the same year, 2006-7, question 25, question 26, and question 27. The question says, without using tables, find the values of the following 3 questions, which are these: cos 315 degree, tan 300 degree, and sine 330 degree. All right. So now, but take note, the moment the question says without using tables, that shows that under trigonometry, it means that the kind of angles that will be given are angles that you are familiar with. We usually call them special angles. They are angles that you can easily get their trigonometric ratios. It is expected of you to know the trigonometric ratios of those special angles, which are 30 degree, 45 degree, 60 degree, okay? 0 degree and 90 degree are like the boundary angles, all right? So now, in this case, each of these angles here has an acute angle equivalent in the first quadrant, such that by the time you will check it, you will realize that those angles are special angles. It's either it is 30 degree, or it's 45 degree, or 60 degree. All right. So now our duty now is to apply the same approach we have for 25 now. Cos 315 degree. Now the first thing is to find out which of the quadrants does angle 315 degree lies. You will see that that lies in the fourth quadrant. That's angles that are greater than 270 degree but less than 360 degree. This work is fantastic because all the 3 angles given here lies in the fourth quadrant. So my duty now is to now try to remember what is the acute angle equivalence of all the trigonometric ratios of angles in the fourth quadrant. So now, permit me to now say that for the fourth quadrant, the acute angle, that's angles between 270 degree and 360 degree. I do know that inside that quadrant, only cosine of angle is positive. Every other trigonometric ratios are negative. So that means that sine theta in that quadrant will definitely be negative. So this is going to be equal to negative of the acute angle equivalence of sine of the acute angle equivalence, which is going to be what? 360 degree minus theta. For cosine, I do know that inside that quadrant, cosine of an angle is positive. So this is going to be positive cosine of the acute angle equivalent, which is still the same thing as 360 degree minus theta. And for tangent of angle, it's going to be negative. And that is tan 360 degree minus theta. I hope that is clear. So now, putting solution to the question now. For question 25 now, I can say that cos 315 degree is the same thing as positive. That's plus cos 360 degree minus 315 degree. What will this give me? This is the same thing as, I can ignore the positive sign. So this will give me the same thing as cos what? Subtract this, that's cos 45 degree. What is cos 45 degree? I don't know that cos 45 degree is same thing as 1 over root 2. Is there 1 over root 2 there? Yes, option A. Sometimes they can decide to rationalize the denominator so that the denominator is a rational number, not irrational as it is. Then to rationalize it, multiply the numerator and the denominator by the conjugate of the denominator. The conjugate of that root 2 is also root 2. Okay, so by the time you multiply, you will get root 2 over 2. That shows that the cos 45 degree is the same thing as 1 over root 2 or root 2 over 2 if the denominator is rationalized. Okay, so this will be 1 over root 2, and that's option A. For tan 300, that's question 26. Tan 300, what's that going to be? Negative minus tan 360 degree minus 300. What would that become? That's negative of what? Tan 60 degree. What is tan 60 degree? I do know that tan 60 degree is the same thing as root 3. That's all. Don't worry, maybe we'll check another video. We'll try do another video where we will need to state each of those, or you can just check your trigonometric, your any of the mathematics textbooks, and try as much as possible to memorize the trigonometric ratios of those special angles. You will need it here, okay, or in a place like this. So the result of this is going to be minus root 3. So that's option what? Option C. If you make mistake to ignore the negative sign, you see option A is waiting for you. You have to be very, very careful. So 27 now, the last part of that is sine 330. You should know that sine of angles in the fourth quadrant is also negative. So this is going to be minus sine 330, sine 360 degree minus 330 degree. And that's going to be what? Minus what? Sine 30 degree. What is sine 30 degree? I know that sine 30 degree is 1 over 2. 0.5. Abi? Yes. So that's going to be minus 1 over 2. And that settles it. Where's minus 1 over 2? Wow. If you ignore the negative sign, you get 1 over 2. You can even jubilate. Meanwhile, it is rubbish. So this is going to be this. So I think it's as simple as that. I think this question should not take you more than 5 minutes to solve the 3, provided you know the basic thing you need to know. So we have another question, 2006-7, question 28. This is not directly the trigonometric ratio of this angle. This one is just on conversion of angles from degree to radian. So this is very simple. We just need the conversion rates. Now we do know that angle 360 degree is equivalent to 2 pi radian. Alright, the short form of radian is rad. So that shows that from here 1 degree will be the same thing as or better still, you can make it anyway. 1 degree will be equal to, or will be equivalent to divide both sides by 360. So that will be 2 pi over 360 rad. Okay, which is going to be equal to what? Pi over 180 rad. And if you want to get 1 radian, that's 1 rad is going to be equal to what? Divide both sides by 2 pi in degree. So that's going to be 360 degree divided by 2 pi. Alright? So and that will, what am I saying? Sorry. Yes, I'm correct. So 1 rad is going to be equal to 360 degree divided by 2 pi. So now I am to convert 300 degree to radian. So what would that become? This one is in degree now. So that shows that now 300 degree is the same thing as 300 multiplied by 1 degree. Okay, so now what is 1 degree in radian? 1 degree in radian is what? Pi over 180 rad. So that I can say that 0 here 1, 0 can terminate 0. That's saying dividing both the numerator and the denominator by 10. I can also get another common factor. 3 can also divide this. No, not 3, 6. 6 divide this, we have 5. 6 divide this, we have 3. So the final result of this is 5 pi, 5 times pi is 5 pi over 3 rad. And that is what? Option C. It's very simple. Okay? Another way of saying it, if you don't want to go through this, is just know that anytime you are converting from degree to radian, divide by 180. Alright? And attach pi to it. It's as easy as that. Okay? And if you want to convert from radian to degree, just divide by 360. Alright? That's same year 2006/7, question 29. This is another question set on product formula. The question says the product formula for sine alpha cos beta can also be written in the form, which one of them? Now we will see that we can see angle alpha and angle beta as a compound angle here. Okay, sum or difference. So one of the things we can do to verify which one of them is to see how we can rewrite. What do you think sine alpha plus beta, what do you think this will give us? Sine, okay, recall that sine alpha plus beta, what would this one give us from trigonometric ratios of compound angle? That's addition formula. This will give us what? Sine alpha cos beta plus cos alpha sine beta. I hope you remember this. Then what of sine sine alpha minus beta? What do you think this will give us? This will give us sine alpha cos beta minus cos alpha sine beta. we have to use this because we do know that from the addition formula for sine, we get a result that combines both sine and cosine together. Okay, because you could have asked me how come I didn't use cos alpha plus beta or cos alpha minus beta. I do know that the expansion of that will not give me combination of sine and cosine. That's for cosine. All right, so this is the appropriate expression to make use of. So my duty now is this: I can see sine alpha cos beta here, and that's what I'm looking for. So what can I do if I take this as my equation 1 and I take this as my equation 2? Check something. This is starting with sine alpha cos beta. See sine alpha cos beta here, sine alpha cos beta. But this is cos alpha sine beta. They are not the same thing. Okay? So my duty is to look for a way to terminate this. So I'm going to see this, okay, as simultaneous equation in two variables. In fact, precisely trigonometric simultaneous equation now. So I will look for a way to terminate these two terms. And because they are the same, see the sign of this is positive, the sign of this is negative. Do you know that if I add this together, it will automatically become 0? That will be terminated. This particular term in the two equations will be terminated. So to make the equation balance, if I can add this to this, then I must add this to this and add this to this. That is what will propel me to say add equation 1 to 2. In my mind, I do know that once I add equation 1 and 2 together, this particular term will be terminated. I hope you understand that. So see, now I will say that add equation 1 and 2 together. Once I do that, this will make me write here sine alpha plus beta plus sine alpha minus beta. This will be equal to, the moment I add this, because they are the same thing, I'll give me 2 sine alpha cos beta. The moment I add this, that will give me 0. So I can smile now because what I'm looking for is smiling at me. See it here, sine alpha cos beta. That's what I need to find. So if I'm to look for this, that means I have to look for a way to terminate these two. So that means I can divide both sides by 2. The moment I do that, these two will be terminated. Okay? And maybe to make it a fast approach, dividing both sides by 2 is the same thing as multiplying both sides by half. 1/2. Okay? So that means I can imply from here that 1/2 multiplied by this, I will have sine plus alpha minus beta. And by the time I use half to multiply this, it will terminate the 2. I will have sine alpha cos beta. So the expression for sine alpha cos beta is simply this. Then which of the expression? Oh, cosine no, cosine no. This and this is terminated. Oh, this is looking like this, but this one is starting with negative, and this is even negative, not even because this is negative. It should be addition. So this is the perfect expression. Option B is the right answer. Question 30 of the same 2006-2007 says that convert the angle 3 pi over 2 radian to degrees. So you don't need to panic, we just need to make use of our, we do know, we recall that that 2 pi radian is same thing as what? 360 degree, which means that what? 1 rad, or better still, maybe to make it easy, okay, that means 1 rad will be the same thing as what? 360 degree divided by 2 pi. You can as well say it is 180 degree over pi. Alright? Now, if that is the case, therefore, what is my 3 pi over 2 rad going to be? This is the same thing as 3 pi over 2 times 1 rad. I hope you agree with me. So what is 1 rad? So this same thing as 3 pi over 2 multiplied by 360 degree divided by 2 pi. So this pi can terminate this pi. Am I right? 2 and 2 will give me 4. So 4 in 360 degree, that's going to be 90 degree. So what is 3 times 90 degree? That will give us 270 degree. Very simple. It's as simple as that. Okay. So this is the last question on trigonometry in the year 2006/7. So question 31. It says find the value of sine 105 minus sine 15. Okay, so here they expect you to make use of the product formula, or one of the product formulae. So I do know, it's just that you need to be conversant with those product formula. But let me state this, I can now state other ones. Recall that sine of angle P minus sine of angle Q, the result of this nonsense is going to be 2 cosine of sum of the two angles divided by 2, then sine of the difference of the two divided by 2. That's just it. So my duty now is to now follow suit. I have sine 105 minus sine 15 degree. If you follow the pattern, what will this give us? It will give me 2 cos 105 plus 15. They are both in degree, divided by 2. Then I have sine 105 minus 15 degree divided by 2. So this will give me 2 cos 105 plus 15. That will be 120. 120 degree divided by 2. That's going to be 60 degree. Then I have sine. What is 105 degree minus 15 degree? That should give me, is that not 90 degree? Yes, that's 90 degree. 90 degree divided by 2, that's 45 degree. So I have 45 degree. Take note of questions like this. Most of the time they will always end up as an trigonometric expression of a special angle, okay, or trigonometric function of special angle. So in this case, what is my cos 60 degree? Cos 60 degree is 1 over 2. Yes, because this is a complementary angle to angle 30 degree. So cos 60 and sin 30 are the same. Since I know sin 30 is 1 over 2, so definitely cos 60 is going to be 1 over 2. So I have 2 multiplied by 1 over 2 multiplied by what is sin 45? Sin 45 is the same thing as 1 over root 2. Okay, so 1 divided by root 2. Am I right? Yes, I'm correct. So this will give me what? This terminate this. So what do I have? I have 1 over root 2. It's as simple as that. And what's the option there? Option B. It's the same thing as root 2 over 2. I guess it's a typing error. I suspect it's a typing error because they cannot leave these 2 here. They want us to find the value. These 2 are the same thing. So look at it. If you study the pattern, this is negative 1 over root 2. This is positive 1 over root 2. So this is root 2. I expect maybe it was a typing error. I guess they wanted to put minus 1, minus root 2. However, if they did not, either of the two is the answer. But from what I've gotten here, B, option B is the answer. Thank you. Now, we have come to the end of all the trigonometric question in the year 2006/7. In the next video, I would have to look at the year 2008. Now we are still going to year 2020 because the questions are, and as we progress, you will see that we will be coming in contact with some other trigonometric ratio questions that we have solved previously, and that will make it easy for you to understand this topic, provided you have been able to practice as much as possible. I want to say to you that do not fear any question on trigonometry, come what may. You don't need to be afraid. Just try as much as possible to solve as many questions as you can. I know that the time is a bit short towards your Jupeb exam, but as much as you can access, or as much as you can, see questions to solve, don't run away from them. Ensure that you put solutions to them. I encourage you, if you still have questions as regard what we have done, or maybe there are some questions that have not been solved and you still want us to put solutions to them, you can drop them in the comment section below. I want to declare and I decree that all that we have learned within this period of explanation, I declare that they are retained in your cerebrum in the name of Jesus. When you need them during the examination, you will never forget any one of them in the name of Jesus. The power of the Most High God will come upon you mightily to recall all the concepts that you have ever read and learned from books or videos like this in the name of Jesus. And you will come out of your examination hall with good success in the name of Jesus. God bless you.